Welcome back to Djji Tutorials. Today we are diving into the real number system and the root of a number. The real number system is a set of numbers that includes all the numbers you commonly use in everyday math. It's made up of several different types of numbers, all of which can be found on the number line. Here's a breakdown of the parts of the real number system. 1. Natural numbers. These are the counting numbers. 2. Whole numbers, natural numbers plus 0. Integers, whole numbers and their negative counterparts. Rational numbers, numbers that can be written as a fraction or ratio of two integers. These numbers either terminate or repeat when written as decimals. Irrational numbers, numbers that cannot be written as a simple fraction. Their decimal forms are non-terminating and non-repeating. Natural numbers, definition: the set of positive counting numbers. Examples 1, 2, 3, 4, 5 and so on. Note, some definitions, especially in computer science or some textbooks, include 0 in natural numbers, but traditionally natural numbers start from 1. Whole numbers, definition: the set of natural numbers plus 0. Examples 0, 1, 2, 3, 4, 5 and so on. Integers are whole numbers that can be positive, negative, or 0, but they don't include fractions or decimals. Examples of integers: positive integers 1, 2, 3, 100. Negative integers -1, -2, -3, -100, 0, 0. So the set of integers looks like this: -3, -2, -1, 0, 1, 2, 3. Rational numbers are numbers that can be expressed as a fraction or ratio of two integers. In other words, a number is rational if it can be written in the form a over b, where a and b are integers and b is not equal to 0. Examples include 1/2, where a equals 1 and b equals 2, -3/4, where a equals -3 and b equals 4, 5, which can be written as 5 over 1, and 0, which can be written as 0 over 1. Irrational numbers are real numbers that cannot be written as a simple fraction or a ratio of two integers. In other words, they cannot be expressed as a over b, where a and b are integers and b is not 0. Key characteristics of irrational numbers include their decimal expansions going on forever without repeating, and they do not terminate or form a pattern. Common examples are pi, approximately equal to 3.14159265535. The square root of 2, approximately equal to 1.414213562, and Euler's number, approximately equal to 2.718281828. Unlike rational numbers such as 1/2 or 3.75, these numbers cannot be neatly written as a ratio of whole numbers. The root of a number refers to a value that, when multiplied by itself a certain number of times, gives the original number. Finding roots by factoring. Let's say you have a quadratic equation, for example, x squared minus 5x plus 6 equals 0. Here are the steps. First, factor the equation. Look for two numbers that multiply to give the constant term, which is 6, and add to give the middle term, which is -5. The factors of 6 are 1 and 6, and 2 and 3. 2 and 3 work because -2 times -3 equals 6, and -2 plus -3 equals -5, so x squared minus 5x plus 6 can be factored as x minus 2, x minus 3. Next, set each factor to 0, so x minus 2 equals 0 or x minus 3 equals 0. Finally, solve for x. This gives us x equals 2 or x equals 3. These are your roots. Using a calculator, specifically the graphing method. If you have a graphing calculator like a TI-84 or something similar, here's how you can find the roots. First, enter the equation. Go to the y equals menu and type in the function x squared minus 5x plus 6. Next, graph it by pressing graph to view the parabola. To find the roots, or x-intercepts, use the second key and then trace to access the calc menu. Choose 0. Move the cursor near one root and press enter. Set the left and right bounds, then guess. Repeat this process for the second root. The x values where the graph crosses the x-axis are your roots. Radicals are mathematical expressions that involve roots, most commonly square roots. A radical expression uses the radical symbol to indicate the root of a number or expression. Here's a breakdown. The radical symbol indicates a root. The radicand is the number or expression inside the radical symbol. The index is the small number, if any, outside the radical, indicating the degree of the root. If there's no number, it's assumed to be 2, which is a square root. For example, the square root of 9 is 3. The cube root of 8 is 2. The square root of x is just the square root of x. Radicals are often used in solving equations, simplifying expressions, and in geometry, such as calculating the length of the hypotenuse in a right triangle. Hope this is useful and you will share with other students. Please don't forget to like and subscribe.